Hello guys, good morning. You are welcome to my YouTube channel, the SPC Tutorials, and my name is Tutor Joseph. In today's video, I shall be taking us Chem 113, a topic called, or a subtopic called chromatographic procedures. Chromatography can be defined as a process whereby color substances are separated from every other component. For such substances to be separated in a column, now the components must migrate. They must migrate at different rates. All right, please. This is a criterion for separating components in the column, which means that the components in the column must have the ability to migrate at different rates. Please take note of that. Which means the higher the polarity of a component, the lower it the lower it moves slowly, which means that the lower the polarity, the higher the rate at which it will migrate. So that is how it is. Please, this is a criterion for separating substances in the chromatograph. Now we have different types of chromatographic procedures, or different types of chromatography. Now we have the column chromatography. This column chromatography is otherwise called adsorbing column chromatography. All right. During chromatographic procedures, two things are required. One, the stationary phase, which is usually static. Stationary, it is static. It does not move. While the other one is the mobile phase. The mobile phase moves. It moves. Okay. Now, please, in this topic, we are going to be focusing on the mobile phase. What is used as the mobile phase and what is used as the stationary phase. Take note of that. In a column chromatography, the stationary phase is adsorbent. The stationary phase is adsorbent. I not say ab, it's adsorbent. Then the mobile phase is eluent. I can say eluent solvent. In column chromatography, the stationary phase is adsorbent, while the mobile phase is eluent solvent. Now, what is importance of this column chromatography? It is used in drug. It is used in drug industries. It is used to remove impurities from compounds. It is used to remove impurities from compounds. It's also used in the isolation, identification, and purification of compounds. The first step, stationary phase, is usually an absorbent. The mobile phase is an eluent. Now, and the industry that is likely to use column chromatography is drug industries, and it is used to remove impurities from compounds. It's also used as isolation, identification of and sorry, it's end, not of, and purification of compounds. So please take note that. Now, what are some examples of these adsorbents, and what are some examples of these eluents? Now, examples of adsorbent used during or in the column chromatography, examples of adsorbent used as stationary phase in the column chromatography are: we have starch, we have sucrose, we have sodium carbonate, and activated what? Alumina. So all of these are what? The stationary phase used in what? Column chromatography. While examples of elements used in column chromatography, which is what? The mobile phase, we have the acetone. Acetone is used as mobile phase. We have benzene. Benzene is used as mobile phase. We have ethyl acetates. Ethyl acetates. Acetates is used as what? Mobile phase. Which one again? Glacial acetic acid. It's also used as what? Mobile phase. Which one again? Methanol can also be used as what? Mobile phase. Ethanol can also be used as what? Mobile phase. Cyclohexane, petroleum ether is also used as what? Mobile phase, which means that all these solvents mentioned are all used as what? Mobile phase during what? The column chromatography. While these solids mentioned are all used as what? Stationary phase in the column chromatography. Please note, NB. When nitrogen is used to force the components through the column in column chromatography, it is called what? A flash column chromatography. All right, when nitrogen is used to force the solvent, to force the component through the column of this column chromatography, it is called what? A flash column what? Chromatography. So please take note of that. Now, number 2 type of chromatography is the paper chromatography. Paper chromatography. Number 2, paper chromatography. Paper chromatography is otherwise called what? Liquid chromatography. Paper chromatography is also called what? Liquid what? Chromatography. The stationary phase in paper chromatography, the stationary phase is water. All right, the stationary phase in paper chromatography is what? Water. While the mobile phase is organic solvent. The stationary phase is water and the mobile phase is what? Organic what? Solvent. So these are the stuffs used in what? Paper chromatography. Now this stationary phase, which is what? Water, is supported on the cellulose of the paper by hydrogen bond. So which means that hydrogen bond is concerned with what? Paper chromatography. The stationary phase is water and the mobile phase is what? Organic what? Solvent. Now, this water, as the stationary phase that is usually static, is held in position on the cellulose of what? The paper chromatography by what type of bond? Hydrogen bond. So please take note of that. Now, paper chromatography is used to separate smaller components that are very small in nature. Examples are amino acids. We have sugars. We have what? Plants, pigments. So all of these are separated using what? The paper chromatography. Now, When amino acids and sugars are tested with some components, there's a change of what color. Now, for example, now when amino acid is tested with ninhydrin, when amino acids are tested with ninhydrin, it turns blue or what? Purple. Please take note of this. When amino acids are tested with ninhydrin, it turns blue or what? Purple. But when sugars are tested, okay, when sugars are tested with phenylamine and benz 1,2-dicarboxylic acid, it turns brown or red. Please take note of this color change. When amino acid is tested with a ninhydrin, it turns blue or purple. But when sugar is tested with phenylamine and benzoate 2-dicarboxylic acid, it turns brown or what? Red. Please take note of that. It is very, very important. Now, retention factor is associated with paper chromatography. Okay, the retention factor is associated with what? Paper chromatography. Now, retention factor, which is written as RF, retention factor is associated with what? Paper chromatography, and the formula is distance moved by the compound, distance moved by compound over distance moved by solvents fronts. Alright, so the full meaning of RF is what? Retention factor, and it means the ratio of the distance moved by the compound to the ratio of the distance moved by the solvent front. So all of these are associated with what? The paper chromatography. Please take note of this. Amino acids turn blue or purple when tested with what? Ninhydrin, but sugars turn brown or red when tested with what? Phenylamine and benzoate 2-dicarboxylic acid. Take note of that. Now, the next type of chromatography is the thin layer chromatography. Thin layer chromatography. All right. Thin layer chromatography. All right. On that note, guys, thin layer chromatography is another type of what? Chromatography. Now, we can see that paper chromatography is even a type of what? Thin layer chromatography. Paper chromatography is a thin layer of what? Is a type of thin layer what? Chromatography. Now, in thin layer chromatography, the stationary phase is an adsorbent such as alumina, silicon gel, and Kisego. Kisego. Kisego is called what? A sealite. Alright, in thin layer chromatography, as that paper chromatography can be said to be a type of what? Thin layer what? Chromatography. In thin layer chromatography, the stationary phase is what? An adsorbent such as what? Alumina, silicon gel, and what? Kisego, also called what? Sealite. Now, the most widely used adsorbent is what? The silicone gel. It is the most widely used stationary phase in thin layer chromatography. Please take note, a moist silicone gel permits liquid partitioning. All right, partitioning. Wet or moist silicone gel permit liquid partitioning. But oven dried silicone gel, that is silicone gel that has been dried by oven, permits liquid solid chromatography. All right, moist or wet silicone gel permit liquid partitioning. Take note of that. Then oven dried silicone gel permit liquid solid partitioning. Please, liquid solid partitioning. So please take note of that. This thin layer chromatography is used as isolation, identification, and purification technique. So that is all about the thin layer chromatography. Take note of that. The next type of chromatography is the ion exchange chromatography. Ion exchange chromatography. Ion exchange chromatography. Ion exchange chromatography. Now, this ion exchange chromatography is restricted to just ionized compounds. Compounds that have ions. It's just restricted to ionized compounds. Okay. It's also called liquid solid chromatography. Liquid solid chromatography. Now, during ion exchange chromatography, resin is used. Resin is used, and there are two types of resin based on this context. We have the cation exchange resin, and so we have the anion exchange resin. So these are the two types of resins as used in this context. Now we have the cation exchange resin has two compounds. The sulfonic acid, and two, the carboxylic acid, COOH. The cation exchange resin has two compounds, the sulfonic compound and the carboxylic acid. Now, when the cation exchange resin is covalently bonded to the sulfonic group, it's called a strong cation resin. Cation exchange resin has two compounds, this and this. But when this cation exchange resin is covalently bonded to the sulfonic group, it is called strong cation resin. But when it is linked to the carboxylic acid, it is called weak cation resin. You can see that it's called weak cation resin, that is to sulfonic acid, weak cation resin to carboxylic acid. So the next one is anion exchange resin. Now, this type of resin is used during treatment of domestic water. During the treatment of what? Domestic water. You know, for water to be supplied to township, it must undergo certain procedures. It must be purified. It must be made clean, and all the germs in it must be killed. Now, anion exchange resin. Now, resin is the resin is a natural occurring what or salt. Another name for resin is what? The IUPAC name of resin is sodium aluminate triazosilicate 3. Alright, the IUPAC name of resin is sodium aluminate triazosilicate what? 3. Look at the chemical formula. So this is the chemical formula of what? Resin. Sodium aluminate triazosilicate what? 3. Now that is for that. Now, you know, two metals are present in hard water. You know, we have calcium bicarbonate and magnesium what? Bicarbonate. These two idiots are responsible for the hardness of what? Water. Hardness of what? Water. Permanent hardness of what? Water. These two ions are what? They are responsible for the hardness of water. Now, during this process, what happens? Now, since we have sodium present in this resin, as soon as this hard water is passed through resin, now there's what we call electrochemical series. Electrochemical series is the arrangement of elements in order of what? Reactivity and the readiness to displace less reactive ones. Chemical series is the arrangement of what? Elements based on what? Their reactivity and the readiness to displace what? Less reactive ones. You know, in the electrochemical series, sodium is higher up in the series. Therefore, it has the ability to displace calcium and what? Magnesium. As soon as sodium displaces this calcium ion and magnesium, okay, it should be 2 plus, and magnesium ion, the water that comes out becomes what? Soft water. Alright, so which means that this anion exchange resin is restricted to what? Purification of what? Domestic water. The process involves passing hardness through this resin. As soon as water is passed into it, what happens? The sodium present in it to displace these two ions responsible for the hardness, and you have what? Soft water. So please take note of that. It is very important. Now, the last type of chromatography that we are to round off with is the gas chromatography. Gas chromatography. Gas chromatography. In this gas chromatography, I'm going to be giving us an assignment. You don't expect me to give you everything. An assignment to be given, and you must do it, else you'll not make heaven. All right. The fifth one is what? Gas chromatography. Gas chromatography. Another name for this gas chromatography is vapor phase chromatography. Another name for this gas chromatography is what? Vapor phase chromatography. That is vapor phase chromatography. Alright, this is another name for this gas chromatography. Now we have two types of gas chromatography. We have one, gas liquid chromatography. That is gas liquid chromatography. And so we have gas solid chromatography. That's gas solid chromatography. So these are the two types of what? Gas chromatography, gas liquid chromatography, and what? Gas solid chromatography. Now, in the gas liquid chromatography, the stationary phase is usually a non-volatile liquid. Is a non-volatile what? Liquid supported on the inert solid. All right. The gas solid chromatography, the stationary phase. Now, the stationary phase is a non-volatile what? Liquid supported on the inert what? Solid. Okay, but that's in the gas chromatography. But in the gas solid chromatography, the stationary phase is the inert solid itself. Is the inert solid itself. All right. Gas liquid chromatography has a stationary phase as what? A non-volatile liquid supported on the inert what? Solid. But in gas solid chromatography, the stationary phase is what? The inert solid itself. Therefore, the mobile phase of both the gas liquid chromatography and the gas solid chromatography is unreactive gas. Unreactive gas. So unreactive gas is used as mobile phase for both gas liquid chromatography and what? Gas solid chromatography. Now the equipment, excuse me, shut the door. Now the equipment or instrument used in gas chromatography is called a chromatograph. Take note of that. The instruments or equipment used, hope it's recording now. Yes, the equipment used in gas chromatography is called what? A chromatograph. A chromatograph. So this is the instrument or equipment used in a gas chromatography. Now, a gas chromatography must comprise the following. It must possess the following. 1, it must have oven. 2, it must have a detector. 3, it must have a sample injection system. 4, it must have flow. Okay. It must have recording. It must have oven, detector, sample injection system, recording system. Is it another one? So it must possess all of these. That is gas column what? Exactly the 5th one. It's one that just entered my head now. Number 5 is what? Carrier gas supply system. So these 5 entities must be present in what? In a gas chromatography. Now, oven, detector, sample injection system, recording system, carrier gas supply system, they have their own function, but I'll give us some to take home. Now, you are going to be doing for me detector. Okay, let me start with the one I have to do now. Now, oh God. Now, the carrier gas supply system, all right, has its mobile phase as what? A carrier gas. The carrier gas is what? The mobile what? Phase. The carrier gas is what? The mobile phase. Then the gas is inserted in a container, is inserted or is pressurized in a container. All right, and this carrier gas also possesses gauges. It has gauges. It also possesses flow meters molecules. This carrier gas supply system comprises these ones I've listed so far. Now, these flow meters molecules remove impurities and water from the gas. So which means that in the carrier gas supply system, the function of the flow meters molecules is to remove impurities and water from what? The gas. So please take note of that. It is very, very important. And again, is there any other one? We now have what? Solid support. Solid what? Support. Now, of course, they are actually used to put in place the stationary phase, and a good solid support must have certain characteristics. What are examples of good solid support that can be used as what? Solid support. We have the chromosome W. We have the chromosome P. All right. We have the ember cell. We have the ember cell. We have the Q-segel. We have the Q-segel. We have the Q-segel. Okay, let me just hold on, please. Hold on. Let me see your light here. Now, all of these are. There's one again that's called stomachal. Okay, stomachal. Now, there's what we call diatomaceous earth. All right. A good example of a diatomaceous earth is Q-segel and fireworks. All right, they are examples of what? Diatomaceous what? Earth. Take note of that. Now, a good solid support must have the following. A good solid support must have the following. One, it must have high specific surface area. It must have high specific surface area. 3, it must have mechanical strength. Please excuse me. Sorry, it's these kids, so I have to just tell them to stop disturbing me. I've driven them out already. Now, I said a good solid support must have the following: high specific surface area, mechanical strength, and number 1 to number 3. Number 3, it must be chemically inert at high temperature. It must be chemically inert at what? High temperature. 4, it must have appropriate particle size and what? Shape. That is, the shape or size used must be what? Appropriate. It shouldn't be too big or what? Too small. It must be what? Moderate. Number 5, which is the 5th one, it must be able to be amended. Amendability to being wetted by liquid what phase, which means that for a solid support to be used, such solid must be able to what? Absorb, or must be able to be what? Wetted or absorbed by what? Liquid phase, which is what? Liquid molecules. Now please, I told us that the carrier gas is used as what? The mobile phase in carrier gas supply system. Okay, but what are some examples of these carrier gas? Carrier gas. Please, argon is there, helium is there, nitrogen is there, hydrogen is there, okay, yes. So these elements are used as what? Carrier gas. They are what? The mobile phase. They are what? The mobile phase. Please, a good carrier gas which is used as what? Mobile phase must be chemically inert. Must be what? Chemically inert. A good carrier gas used as mobile phase must be what? Chemically what? Inert. Okay? Chemically inert. Okay, take note of that. That it must not be what? Reactive. So please take note of that. Now we now have what? Detector. Detector is used to, okay, it responds to a slight change of the solutes in what? In a component. All right, detector. Now we have three types of detector. 1, 2, 3. Okay, you are going to be doing them for me. You are going to, that is going to be your assignment. Now we have the thermal conductivity detector. That is thermal conductivity detector. So we have electron capture detector, and we have flame ionization detector. Flame ionization detector. Let me capital letters. So that is all about what? Chromatography. So in my next video, I shall be doing assessment of what? Pure substances. How are pure substances what? Assessed? We have the visual inspection, we have the olfactory attributes, we have the mist melting point, we have the melting point, we have the boiling point, and we have what? Refractometer. All of these are ways to detect what? The purity of a particular what? Substance. So if you know you have learned something, please, as you have watched it, please endeavor to subscribe, like, share, and comment. Do have a wonderful day.